Good morning, friends. So I'm Douglas. I'll be walking you through this discussion of, managing your Lakehouse from taking a DBA perspective. So first off, who here has identified or identifies as a DBA? Database administrator, database architect? Okay, all right, very good. How about product owner, platform owner? Yeah, some more? All right, very good. So 6 ways to know if you're a DBA. Do you have a lakehouse, a data lake, or a data warehouse, or database? Pretty obvious. Do you manage or are responsible for data performance, service levels to your users, customers? Do you get involved in sizing workloads and jobs and clusters, managing costs, as an example? Are you in charge of provisioning data access to your users? Do you find that challenging? Do you get excited about how the Lakehouse works, perhaps? Most off, does this look like you? I used to look like this. So there are a lot of great performance talks, sessions this year and in past years on YouTube. But I want to address how do you scale as a DBA. So I'm going to introduce the scalable performance tuning process. There'll be code, don't worry. There'll be code and graphs and analysis and just some advice. So the tuning process. First off, there's the analysis phase. What's going on, but what's going on as a whole. You look at your support channels, your emails, your snow tickets. You look at your operational logs. Are your jobs failing? Are they getting longer and longer? You look at the metadata that you can find in your Lakehouse. And then additionally, you're working with teams, kind of listed here on the right. And you're working with them and you're getting feedback. And then you prioritize. Are you prioritizing for service levels, innovation, cost and budget, uptime? When you do find something, an insight, you solve a problem, hopefully you're communicating that to your community. You're posting that out there so that others can learn from that and do better with their next set of jobs that they build. You're participating in discussion threads in Slack or Teams. You're engaging with your stakeholders in meetings to, check in with them on expectations. Meetings with different teams, lunch and learns. Perhaps you're leading those. Your community is your platform, your cloud ops team, your application support teams. You want to make sure that they are well informed in heading off performance issues early on. Talk to your enterprise scheduling teams. How many jobs are exceeding their SLAs, are failing? Work with your account team, your SA, your CSE, your SSA, like myself. You may have financial ops teams running around wondering why the cloud costs and Databricks costs are going up in certain ways. And your cloud ops teams, they have lots of valuable logs. Again, take this data, categorize that. What areas should you fix? Again, I've seen some people in this role that are just going from fire to fire to fire. But how do you take that and say, how do you solve it holistically? And which one should you solve first, if you will? So in terms of metadata, this talk is going to deep dive on table details and the metadata that you get out of that. Some pretty simple metadata, relatively easy to gather, and it'll get easier in the future, hint, hint, in terms of product roadmap. There's also, file metadata on data that's being ingested into it. That can help drive sizing decisions. We'll get into that a little later in terms of permissions and over-permissioned access. You can scan your users and groups and grants and link that data together. Operational logs. Again, which jobs are failing, running too long. Audit logs. When are people coming in to your system? And so on and so forth. Take all this information, but we're going to drill down on table details and what we can do with that. So first off, collecting the data. Here's some Python code. Nice thing about the Lakehouse is that you can run both SQL and Python, plus all those other languages like SQL and R and Bash and COBOL and Fortran, so on and so forth, on your Lakehouse, but mostly Python and SQL. So in here, we go and capture, we run a SQL query, describe detail on a database and table name, right? And then we write that to a table called DBA helper.tableDetails. This runs per row as a result of this list query. And this run parallel, we'll show that later, but this allows you to run 8, 16, 32 of these in parallel. Because when you have a large lakehouse, like some of my customers, you don't have a few hundred tables, not even 1,000, but perhaps tens of thousands of tables that you need to analyze there. So being able to run this in parallel kind of necessitated this function here. So, and this code is on my GitHub. Here, I'm going wrong way. dmore247 DBA-helper. Save that for later. All right, so what do you get out of describe details on a table? Well, you get this data here. And in particular, the most interesting part of it is the num files and size in bytes. How many files in your table? And the number of bytes, total bytes in your current version of the table. Now, if you go back a few years, like Oracle or SQL Server, you had this information available to you as a DBA, and you'd look into fragmentation of your table, right? Well, fast forward a little bit, with Hadoop, you ran into issues with small file problem, right? Thousands, maybe millions of small files in a table. That's not good. So again, this talk is kind of centered around, physically tuning your tables at scale, kind of like the DBAs used to do. So we're going to take this metadata and we're going to plot it on a scatter plot. And so I've circled some of the outliers. Most of the data is down here. And so outlier number 1 here is, on the y-axis you have 600,000 some files. And you can see that the size of that is probably under a gig or 2. You do the math, you got very small files there. This is one crazy table, I'll tell you. I tried cloning it, and oh my gosh. And then number 2, out on the far right there, is, 60, 70 gigs, right? But it's tough to see on this scale if that's too many files or too few files or not. But 3 is on the x-axis, and it definitely is too few files on there. So let's zoom in. So 3 is definitely there. Again, you see a lot of files in very small tables, so we got some issues there. Zooming in even further, you notice a curious pattern. You see the line there? So who can tell me why there's this cluster at 200? All right, thank you. All right, yes, exactly. So when you do a join or a group by, and you're not using AQE, you're not using auto-optimize or auto-compact, you very likely will end up with a pattern like this. So by visualization, we find this pattern, and then, we can use that information to make some wholesale recommendations to improve the performance. All right, so looking at this data further, plotting it from the largest to the smallest, average file size bytes on the y-axis by table number, sorted by largest to smallest. You get this logarithmic progression. You find that in nature all the time. So I outlined kind of the sweet spot here. The right size file, maybe like 32 megabytes to 256 megabytes. Again, it depends on your overall table size. The 32 megabyte file size is really nice for selectivity, high selectivity, merge performance in there. So on the right-hand side, we can look at optimizing compacting tables, to reduce the overhead and opening files and scan and list costs. On the left-hand side, we have perhaps too few files. We might not be getting the parallelism that we like. We're certainly not going to get the selectivity when we do dynamic file pruning in there. So those we could perhaps optimize and, again, kind of right-size the file. Again, this is all about analyzing what's going on in your Lakehouse, perhaps spread out across the globe, different cloud buckets, and finding out where the problematic areas are. So, and then further drilling into this, this is a very long tail of small tables with very small files and lots of files. So I did filter out the case where you just had a small table and single file. 8K and then smaller, 8 kilobytes. Again, another way of looking at it, you can see most of these tables under half a gig, but some of these have 10,000 files in them. Do the math on there. So how do we address this? Okay, well, first off is upgrade. Upgrade your runtime. If you're on DBR 5.5, upgrade on 6.4, 7.3, 9.1. With each release, the tuning is more and more automatic. We have something now called auto-tune. I'll give a link to read into that, but it's terrific. AQE, again, reducing the number of partitions. Auto-optimize. These things become more and more automatic with each release that Databricks puts out. 10.4, it's great. It reduces some of the conflicts between some of your DBA operations and your ongoing write pipelines. A lot of good stuff. So again, keep upgrading. Number 2 is remove your old overrides. A lot of them may not be useful. Okay, so AQE, we mentioned that. Again, it will kind of calculate the right number of Spark partitions there. So remove your explicit, set shuffle partitions. Give that a try. Upgrade, give that a try. Remove your repartition coalesce. Likely you don't need it. Be judicious in using your DF cache. Again, there's many talks. Daniel Tomes had one a few years ago. I keep going back to that. Many great performance tuning talks. And then lastly is partition by. I know in working Hadoop, going way back, that was like the go-to. Partitioning and bucketing your table. Well, with Delta Lake and most size tables, you don't need that. Between what the stats you get, the delta log, the file pruning, you really don't need to partition. The thing with partitioning is often users will over-partition their table. You have hourly partitions, and you end up with like kilobyte-sized files. Things like that, or partition by high cardinality key. Again, you're going to be incurring costs. Your job's going to be incurring a lot of costs, opening up all those files to read, to listing all those files. Now, we have improvements in our DB SQL and Photon for that, but still, reduce the work that your consumers of the data need to do. 3 is optimize your tables. Databricks just announced open sourcing Optimize on the Delta Lake OSS. That's awesome. And Databricks has had this for a while. But before you optimize them, you want to configure your medium-large tables. And here's some properties. I'm going to walk through some of these. First off is auto-optimize. Optimize the write, optimize the bin packing. Turn these on. You can turn them on at the session level. You can turn them on at the cluster level. You can also turn them on at a table-by-table basis. And do this based on your domain knowledge, your user's domain knowledge of how that table is used and accessed. If you set auto on auto compact, you'll automatically get a 32 megabyte file size. Again, look at this document here, file management. A lot of details for the DBAs that are interested in physically tuning their medium large tables there. If you have a gold table that you're going to be doing a lot of merge into and essentially rewriting a chunk of data, turn on tune file sizes for rewrite. So I mentioned that auto tune. Well, it turns out it'll look at the history of the transactions on the table and say, hey, this is a merge heavy table, and figure it out after 10 or so transactions. But you can do that up front if you know, based on your knowledge, that it's going to be a merge heavy table. One more thing, to improve your write performance. Delta Lake, by default, indexes something like the first 30 columns and calculates stats on them. So first off is put your join keys, your foreign keys, at the top of the list of the columns. Put your predicate columns next to that. And then put all your lengthy blob and string columns towards the bottom of your list. I was doing that a long time ago with the Irwin and Oracle and stuff. That just seemed natural. But in the big data world and in Spark, Delta Lake, it makes sense too. So kind of order it by the importance of those columns and doing your queries. And then you can reduce, now if you only have like 3 join keys and 2 predicates that you're using, you can set the number of columns that you're going to index to 5 instead of 30. So you're going to be saving a bunch of work there. So you're incrementally improving the compute required to write out data. And it matters when you're writing out tens of billions of records. You might not go through all this for the long tail of tables. But as you saw from that logarithmic graph, there's a few tables that really matter. They have like your transaction data in there. They're probably used quite a bit because that's where all your activity's captured. And then the final 2 settings are really around retaining the data. So you can fine-tune those on a per-table basis. Again, depending on your GDPR, CCPA requirements, data retention requirements, your business case, your business requirements. So you can fine-tune this on your tables. And then you can run zorder, optimize zorder, and it'll pick up those settings. You can also do overrides on the command line, but if you did all the configuration up front, then you don't have to do that inside your optimized script. And also, as many of you may know, with auto-optimize turned on, as your job is running, it's automatically optimizing the writes or compacting the files as you go. But so on a periodic basis, maybe daily or weekly, you want to optimize it further. And that's where this comes in. And z-ordering, when you add that, you're essentially building this n-dimensional clustered index. So it's reordering all the bits and bytes in there to help, like when you access let's say, ooh, don't do that. They warned me not to pop my peas. How am I doing? Thank you. All right, so again, based on that locality of reference, if you have data that's accessed frequently together, z-ordering will help you with that. kind of pre-sorts it, can dramatically improve the performance. I think you might have seen that early in the conference. Was it Matei showed a graph? Anyways, so with Z-ordering, the recommendation is you docs just say, Z-order, what do you Z-order by? Well, start with your join keys, because you want to optimize your joins, and then your predicates, your filters on that. Sometimes when you do a join of a large dimension table, you have a filter in there that reduces it to a really small dimension table, right? So you want to make sure that you can find that quickly. And so run optimize with Z-order, daily or weekly on that. Run it when the spot prices are lowest. Save some money on that. It's compute intensive workload. On AWS, use the C5Ds, for example. All right, let's talk about analyze and statistics. Who here has worked on Oracle? Oh, wow. Quite a bit. So, statistics were everything. Find the right index for the query, right? Still applies in Spark. So don't forget this. It gets that initial plan correct. What's your large table and what's your small table? You want to get that right. AQE kicks in after the first read and determines the real size of the file in case the stats are a bit off. But do this, make this a habit. Vacuum. So saves, with Delta Lake, it's copy on write. And so you're making copies of individual files. Smaller files are, the smaller the copy is. So that's good. We talked about that earlier. So you want to clean up those copies as you go. Maybe run this daily or weekly. Again, you can set the retention here. You can set the retention on each table. Also will improve your GDPR data retention. With Delta Lake, you can delete data from massive data sets to be in compliance with these regulations, right to forget. But you actually want to remove the files from cloud storage. So this is where vacuum comes in. And so in summary, you do these and kind of do it in this order. Alter table, optimize, analyze, and vacuum. And that run parallel function will help you do that faster and get full utilization out of your cluster. Okay, so back to a little more softer stuff. So building community. So, set up a homepage, SharePoint, or whatever you have, those discussion groups, learning series. Engage your community, your developers, monthly lunch and learn. You can bring in Databricks people, you can have people, experts within your community, build up people. Let them show their expertise on various topics. Post a wins board. This will help show that your platform is very successful. It's going to help your career, too. People say, oh, look how much they've added to the business. Get user training. A lot of training today. There's online training. A lot of training, just a few hours of training can improve your data pipelines and your data teams. Build up champions for your platform. Identify solution patterns, get those published, get that linked to it. I mean, how many times do you get a question about connecting an OWC driver to your platform? No? Nobody gets that? Or how to diagnose a slow job? Anything like that? Okay. Very smart. Anyway, so you're building community. Again, it's about scaling yourself. Deflecting questions to the community, peer-to-peer answering. At least, you won't end up with me with a shortage of hair. So, in summary, as a DBA, it's all about scaling yourself. Analysis, priorities, communication, and building community. And so, the bonus here. We have some time, so we can go through this. So, again, we can run Python, we can run SQL. So how do we run all these SQL commands in parallel? Well, this is the function that does that. It takes an input as another Python function, which we saw earlier. and a list query, a string. We run that list query. We collect all the rows into a Python list. And if that's not an empty list, then we go and figure out how many CPUs we have on our driver. And then for each of those CPUs, we map that function and apply it to that list. So you can run like 1632 of those describe detail commands, or vacuum commands, or optimize commands in parallel. All right? And any questions on this? In my GitHub, and I have another link for that. Yeah?
So it's not going to return back the result to a data frame, right?
This does not return a data frame here. This just simply calls functions in parallel. The functions may have a side effect of writing to a Delta Lake table. Interesting thing, if you didn't know about the Delta Lake table, is you can have concurrent appends, thanks to ACID properties, right? Thank you, Michael Ambrust. All right, so catalog your data. So this is a case where you're getting in a bunch of data, say change data capture from AWS, DMS, or some other tool. You have directories and directories full of data, raw data, CSV data, all right? So how do you get this metadata, the path, the modification time, and length? How do you get that so then you can analyze it? How many times have you worked with a user engineering team and you ask them how much data you have? How much data is coming in? How many times have you gotten the answer, well, we're not sure yet? How many times have you gotten that way too many times? Yeah, exactly. So help them out, give them some code to do the analysis. It's a wonderful thing to understand how much data is coming in. It helps you size your cluster, your compute, helps you estimate your annual cost, if you will. So what this does is, with a Spark Read format binary file, is it'll go and list all the files and even get the content of the file, if you want, into a data frame. But we're going to drop that content on line 7. But we're going to recurse through the directories, trees. So that's why that's set through. We're just going to look at CSV files in this example, but it could be JPEG files, it could be movie files, it could be what have you. We're going to load that. This function does return a data frame. And then we can display that. We can write that out to a Delta Lake table for further, analysis, descriptive analysis on this. From here, we have the modification time and the length in bytes. We also have a path. People are very predictable in naming things, and they'll add context to the path. Which system did the data come from? Which schema did it come from? Which table did it come from? Which partition did it come from? You can parse the path and create these kind of grouping tags. So you can see if you have certain systems producing data at a much higher rate than other systems, and build these beautiful graphs there. I have some beautiful graphs, but customer data, probably shouldn't share that. So, but anyways, this is how you gather that data. It's pretty straightforward. First time might run for an hour or so, over tens of millions of files. But then you have a lot of data you can analyze for rate of arrival, bytes per hour, annual sizing, so on and so forth. So again, this will be on the GitHub repo. I have a notebook up there at dmore247/DBA helper. Connect with me on LinkedIn or what have you. I think we have a few minutes, 5 minutes for questions.
So we have around 5 minutes, so if anybody has any questions.
Hi, probably a basic one. You did mention in one of the slides to get, to be very particular about partitioning. So I was just wondering, say, if you do not over-partition, let's say you just do it by till the day layer, like year, month, day, and then combine it with optimize. Would you consider that to be a good approach? Like that
Yep.
to be your, let's say, your predicate, and then you have another, let's say, a city column in there that you can use city or maybe something with a slightly higher cardinality, and use that for the Z ordering. Will you then consider that to be a good approach? Like,
Right. So again, a lot of these questions. So the question is around partitioning, say year, month, date, and then maybe city is a business key that you're going to group by or partition, group by on, or do some analysis, maybe even join on. So again, it depends. For your larger tables, then maybe yes. For your tables that are closer to ingest, like on the bronze size, perhaps yes, because you might want to re-ingest a given day or something, yes. But as you get to the serving layer, the gold layer, where the data is being consumed, unless you have tens of terabytes in your table, and those partitions are well over a gigabyte, only then might you consider partitioning. Again, because Delta Lake is capturing that information, the month column in your data, and you can create these what are they called? Synthetic? Generated columns, thank you. You can create these, and those are used by the optimizers. You can create generated columns, split apart your date into year, month, day. You can use that in your queries. You get the same kind of performance, but you don't run the risk of getting small files on there. Now, if your city is used as a predicate or join, yeah, definitely include that in the upper columns, and you'll benefit from that. All right? All right?
So we got time for one more.
Thank you so much. I have a two-part question, non-relevant. Since you said one, I cannot say I have two questions. One is when we are vacuuming. So for vacuum, I have a performance question. We noticed that when we run vacuum, we hit a lot of performance issue. And when we were talking to our Databricks customer partners, they were telling us it's because vacuum is trying to kind of like LS from your files, and that's take the most time. I'm wondering if there is any way around that to improve the performance on vacuum. And the other part is related to the function you were showing to run SQL in parallel. On which actions you suggest that? So I'm thinking, like, it might be my lack of knowledge to ask this question, but I'm thinking if we are having a lot of SQL that running, doing DDL on the same table, and we run those in parallel, are we dealing with race conditions or fighting for resources? Or is there any suggestions you have to run that basically function on SQLs? That what kind of actions you suggest to run that?
All right. Okay, so great. So the first part of the question is about vacuum performance. And the second part of the question is like what kind of restrictions around running SQL in parallel, correct? Yes. So on the first one, clearly you've talked to your Databricks team. They've escalated. They probably told you to upgrade, and that may not have worked. That's perhaps unfortunate. Let's make sure we get that feedback into the product, and they'll tune that. I do remember seeing some bits about doing deletes and things in parallel, but you're talking about the list performance. So that'll have to go like on engineering roadmap. On the second one, like what restrictions? So an example that I was doing, describe details, and then I was getting a data frame and then inserting that into the Delta Lake table. I had to make sure I was doing the append operation. That way, there's no write contention there. When you're doing things in parallel and concurrent, you always want to think about, is it going to create some kind of write contention? We have optimistic locking on Delta Lake tables, but again, you want to design your data flow such that you're not going to encounter any write contention unnecessarily. It's better to design it. So, for example, when you have an operation where you're unioning 4 tables and merging that into a 5th downstream table, you're better off running that as one operation that reads and unions those 4 tables and does the merge, rather than have 4 merges running in parallel, as an example in there. For these operations where you're gathering metadata, I don't know of any restriction in terms of running them in parallel. Of course, there's always the, if the table's being updated while you're running it, you might have some slight, inaccuracies, but, generally that's probably going to be small compared to, directionally you're looking for a list of small tables or a list of really large files to optimize. So you'll still be on track directionally.
All right, thank you everybody coming to today's talk. If you have any more questions, please connect with Douglas offline.
Thank you. Thank you. Thanks a lot. Very nice.